the equation of a circle, and the circle has its center on the origin. Today we are going to look at what happens if we move our circle away from the origin, so the center is no longer at 0, 0. Then your center has a new coordinate, A, B. And the equation for a circle that's not on the origin is x minus a squared plus y minus b squared equals the radius squared. Okay, so let's look at page 6. The equation of a circle centered off the origin. Now what's important in today's lesson is there are a number of formulas for the circle and you have to know the names of those formulas. This one is called the standard form and this one appears on the formula sheet. You can also use this one for circles with centers on the origin because then A and B will be 0 and 0. Therefore, if you subtract them, you will get x squared plus y squared equals r squared. Do you all follow? Okay. Let's look at example 1. Determine the equation of the circle with center minus 2, 3. So if they tell you it's a center, you immediately know that they are talking about A and B. And radius 3. So we start with our standard formula, standard form. Substitute A and B in, as well as the R, the radius, and then you get your standard form or the standard equation for the circle. This is also called the center radius form. Okay, so and from this format, in this format, you can read the radius and you can read the center of the circle. But if you multiply out those brackets and you bring the 9 over to the left hand side so that it's equal to 0, then you call this the general form. So you have the general form, standard form, and center radius form. You must know all those names and how to get to them. Okay, any questions so far? How will you recognize that a certain equation is a circle? How? Yes, you have both x squared and y squared. Then you know it's a circle. Example 2. Determine the equation of a circle with center 4 minus 1. So if I tell you it's a center, you immediately know it's A and B. And a point on the circumference. If you have a point, it's always x and y. If you have a center, it's A and B. Then you start off with your standard equation form. Substitute the center, substitute the point on the circumference. We can combine those two steps in one and then calculate the radius squared because we need the radius squared. You always need the center and the radius squared. We have the center, now we have radius squared. Substitute everything and then you have your circle's equation.
When it's just say determine the equation, must you use the immediate standard form and not carry on to the general form?
Yes. Example 3. Determine the equation of a circle with a diameter at points -7, -2, and 3, 8. Now they don't give you the center and they also don't give you the radius. Draw your picture. Okay, so I drew my picture. What do you need in order to get the equation of a circle? You need two things. What are they? Yes, radius and center. Can I get the center of the circle?
No.
Yes, you can. How? With midpoint. And can I get the radius?
Yes.
Distance formula. Okay. So first get the midpoint. That will be my A and B. And then you use the distance formula to get your radius. You can either use the 2 points on the circumference, or you can use the midpoint, the center, and one on the circumference to calculate your radius. In this case, we use the 2's P and Q on the circumference, and then you just need to divide it by 2 because the diameter is 2 radii. Now that I have A and B and R, you can just substitute it in your equation and then you have your circles equation. Any questions? Okay, that's the end of today's lesson. It's very easy. Analytical is very easy, but it's very long to get to the answer. It takes a lot of steps. Your homework for tomorrow is exercise 2, page 8, number 1 to 3. But I want to quickly mark exercise 1 now, and then you can start with your homework.